Hornets aren't supposed to exist, not like this, not at this size, not with this venom, not with this kind of coordinated intelligence stapled onto a body that's basically a flying kitchen knife. Every other insect on this planet plays by a set of rules. Small body, short life, blind instinct, a few weeks of buzzing around before something bigger eats it. Hornets broke that contract about 100 million years ago and never gave it back. The one you should be thinking of right now is Vespa mandarinia, pronounced Vespa mandarinia, the Asian giant hornet. American reporters spent most of 2020 calling it the murder hornet, and every entomologist in the country made the same tired face when they heard the name. The nickname isn't really wrong, though. It's just underselling what's actually going on inside that body. An Asian giant hornet worker is roughly 2 inches long. Queens push closer to 2 1/4. The wingspan is around 3 inches, which is wider than a business card is tall. Its stinger is 1/4 of an inch of hollow, steel-hard chitin, long enough to punch straight through a beekeeper's protective suit. The venom coming through that stinger contains at least 8 different biologically active compounds that don't belong in the same syringe. Neurotoxins that scramble nerve signaling, cytolytic peptides that rupture cell membranes, enzymes that literally dissolve tissue, a pheromone marker that tells every one of its sisters from a mile away exactly where you're standing, and a compound called mandaratoxin that exists nowhere else in the animal kingdom. You are not equipped for this. Nothing about hornets fits when you compare them to other insects, and that's before we talk about what they do for a living. Start with the basics. Wasps show up in the fossil record around the Jurassic. The oldest identified members of the hornet and wasp family, Vespidae, are preserved in Russian rock layers from roughly 130 million years ago. That's the early Cretaceous. Dinosaurs are still hunting each other across what would eventually become Wyoming and Montana. Flowering plants are still figuring out how to seduce insects. And already, buried in stone, we find the recognizable outline of something with a narrow waist, jointed antennae, and a stinger. The blueprint was ready before the dinosaurs finished dying. By 99 million years ago, in a chunk of amber from what's now Myanmar, paleontologists have found something even more disturbing. Not just fossilized wasps, fossilized wasp nests, bottle-shaped mud chambers with preserved eggs inside them, built by a wasp lineage still around today. Which means construction behavior, brood care, and provisioning strategy were already fully developed, while T-Rex was still tens of millions of years away from being born. Hornets didn't evolve their behavior gradually across the mammal era. They walked into the age of mammals already knowing how to do it. Now consider what it is. A hornet colony is a hive-minded body-shredding operation with a single fertile female at the top and up to a couple thousand daughters underneath her, each of whom is a genetically programmed soldier, forager, engineer, or nurse. The queen starts alone in spring. She chews wood pulp into paper, builds a small papery chamber underground or in a hollow tree, lays her first eggs, hunts alone, and feeds her larvae the pre-chewed insides of other insects. Her daughters take over the labor as they hatch. By late summer, the colony is a machine. And what that machine does, more than anything else, is hunt. Let me get specific about that. A single Asian giant hornet, hunting alone, can decapitate about 40 honeybees a minute. 40 per minute. Using its mandibles like a pair of curved scissors that never get dull. It grabs a bee, snips the head clean off, discards the head, discards the abdomen, and flies away with just the meaty thorax. The thorax is the protein-rich cargo. Back at the nest, it gets chewed into a paste and fed to the larvae. The larvae then secrete a sugary liquid that the adults drink. The larva feeds the adult feeds the larva. It's a closed loop of predatory efficiency, and every Everything else in the environment is fuel. When one hornet finds a honeybee hive worth attacking, she doesn't just start eating. She marks the hive entrance with a pheromone. Then she flies home, and she comes back with her sisters. A raid party of 20 to 30 Asian giant hornets can reduce a colony of 30,000 honeybees to a pile of headless bodies in a few hours. 5,000 to 25,000 bees dead in the first 60 minutes. Then the hornets move in. They occupy the hive. They take the larvae. They take the pupae. They take everything worth carrying home. If you've ever seen video of this happen, you'll notice something. The bees don't run. They can't. Their whole world just fell down around them, and they don't have the software to understand the scale of what's arriving. European honeybees, the kind Americans have in their backyard hives, evolved without ever meeting an Asian giant hornet. When one shows up in Washington State or British Columbia, the bees try to sting it. Their stingers don't penetrate, they just crawl on it. It kills them one at a time without breaking rhythm. Japanese honeybees are the exception. They co-evolved with the giant hornet, and what they figured out is one of the strangest defenses in the animal kingdom. When a scout hornet enters a Japanese honeybee hive, a signal goes out. Within seconds, 500 worker bees rush the intruder and pile onto it. They form a living sphere around the hornet. Then they start vibrating their flight muscles as fast as they can. The temperature inside the ball climbs to about 116 degrees Fahrenheit. The carbon dioxide concentration climbs, the humidity climbs. The bees can survive that. The hornet can't. The lethal ceiling for the hornet is somewhere around 113 to 115 degrees Fahrenheit, and the bees are running the ball 2 to 5 degrees above that. They basically slow cook the intruder to death over about 20 to 30 minutes. That is the scale of what these things are, that the only reliable defense against them is a coordinated cooking apparatus made out of bees. And now the number that should keep you up at night. The margin between the temperature that kills the hornet and the temperature that kills the bee is about 5 to 9 degrees Fahrenheit. That's it. If the bees vibrate a little too hard, they die with the hornet. If they don't vibrate hard enough, the hornet survives, kills them all, and destroys the colony. Every single hornet raid becomes a live experiment in precision thermodynamics, run by 500 bees improvising with their body heat. And they've been doing it right for millions of years. But we're not done with the giant hornet yet, because the sting is its own thing. A honeybee stings you once and dies. Her stinger is barbed. It stays in your skin. Her abdomen tears open. She bleeds out on your arm within a couple minutes. That's the trade. One shot, one life. A hornet does not make that trade. Her stinger is smooth. She can pull it out and re-drive it into you as many times as she needs to. Each stab is a fresh injection, and the injection is enormous compared to any other stinging insect an American would ever encounter. One Asian giant hornet worker carries enough venom to kill about 10 mice in laboratory conditions. A small colony carries enough venom to kill a 150-pound animal, which is you. Being stung, according to the entomologists who've had the misfortune, feels like a hot nail driven into the flesh. That's the first 10 seconds. The venom then goes to work. Phospholipase and hyaluronidase digest the tissue around the wound. Mandaratoxin, unique to this species, attacks the nervous system at the level of nerve signaling. Cytolytic peptides start rupturing red blood cells and muscle cells. In severe cases, the cascade produces kidney failure, liver damage, heart muscle damage, hemorrhaging under the skin, and multiple organ shutdown. In Japan, this animal kills between 30 and 50 people every year. In one 3-month stretch in 2013, in a single Chinese province, it killed 42 people and hospitalized more than 1,600. And here is a detail I keep coming back to because I still don't fully believe it. The Asian giant hornet, when its nest is threatened, doesn't just sting. It also sprays venom, aerosolized, from the tip of the stinger into the air. If any of that spray hits your eyes, the venom permeates the cornea and can cause permanent damage to the internal structures of your eye without the hornet ever touching you. There is a documented medical case in Japan of a 77-year-old man who lost most of the vision in one eye because a giant hornet defending its nest misted him from a foot away. You cannot outrun this thing. In flight, an Asian giant hornet cruises at about 20 miles per hour and can push into short bursts closer to 25. Its home range is measured in miles. If you disturb a nest, the alarm pheromone released by the first defender can bring the entire colony onto you within seconds, and once you're marked, running just spreads the scent. Picture the setup for a moment. You're on a hiking trail in the Cascades or the Great Smokies. A single hornet the size of your thumb lands on the back of your hand. You feel the weight of it, which is more weight than an insect should have. You feel the vibration of the wings settling. And whatever you do in the next 2 seconds, whether you swat, freeze, or run, is going to be judged by the chemistry the animal releases from its abdomen. Kill it clean and you might be fine. Kill it and get any of its bodily fluids on your skin, and you have just applied a homing beacon that broadcasts through the trees for a quarter mile in every direction. Every hornet within range now has your coordinates. Now zoom out, because Vespa mandarinia is only one of about 22 species in the genus Vespa. There are yellow hornets, black hornets, banded hornets, tropical hornets. There's the European hornet, Vespa crabro, which has been established in the eastern United States since the 1800s and is the only true hornet native to any part of the country. There's the yellow-legged hornet, Vespa velutina, which was accidentally shipped from Asia to France in 2004 in a load of pottery, and which has since colonized most of Western Europe, killed off a significant fraction of the honeybee industry in Spain and France, and turned up in Georgia in 2023. Every single one of these species runs the same basic playbook: paper nest, female-driven colony, meat hunting, chemical warfare, coordinated raids. They are, essentially, the same solution to the same problem, evolved and re-evolved and refined over the last 100 million years. The math keeps working, which is why hornets are still here, and why the moths, the beetles, the crickets, and the flies that share their airspace have spent the entire Cenozoic developing tricks to avoid being turned into hornet larva food. But the deepest weirdness is what a hornet colony actually is, considered as a single thing. By itself, a hornet is not smart. It has a brain the size of a poppy seed. It runs on hard-coded rules and chemical signals. It can't reason. It can't plan. It can't remember your face. But put a couple thousand of them into one nest, connected by pheromones and vibrations and shared body heat, and something else emerges. The colony learns which trees have prey. The colony remembers where the last raid was. The colony reallocates workers between hunting, nest defense, and larval care based on what the season is doing. The colony makes decisions no single hornet is capable of making. It's a distributed brain, running on wings, and its only long-term goal is producing more of itself, which raises the real question: what is a hornet, actually? If the colony is the organism, then the individual hornet stinging your arm isn't really the animal at all. It's a single cell of something much bigger, thrown at you like an antibody. When you swat it, you aren't killing a hornet. You're wounding a distributed body that will remember you, mark you, and send more cells. Beekeepers know this. Farmers who've disturbed underground nests in the Appalachian foothills know this. The rule they pass down is simple. If one hornet finds you, walk. If 2 find you, run. If a 3rd finds you, you probably won't outrun what's coming next. This is where the insect stops making sense in normal biological terms and starts feeling like something borrowed from a different chapter of Earth's history. And in a way, it is. Sociality in wasps, the same colony as organism logic, was already in place before mammals were anything other than mouse-sized hiders in the underbrush. Hornets watch the dinosaurs die. They watched the first primates climb into trees. They watched us leave Africa. And they were doing what they do now the entire time, building paper, killing insects, feeding larvae, running the machine. There is a moment in every hornet story where the natural response is to say, kill them all, wipe them out. And the moment you say that, you have to remember what they do that we need. Hornets are apex insect predators. They eat caterpillars, flies, beetles, and other wasps by the metric ton. They pollinate a wide range of plants as adults foraging for nectar. In some cultures, the larvae are food. In others, the venom is being studied for potential cancer therapies because some of those cytolytic peptides that dissolve human tissue also happen to be very good at selectively targeting tumor cell membranes. The animal that could kill you might one day help save you. That's the shape of the deal that hornets have been offering the rest of the biosphere for the last 100 million years. They are useful, they are essential, and they are absolutely willing to end you if you get in their way. Every ecosystem that has them has adapted to living around them because there was never a choice. And every ecosystem that hasn't had them until recently is finding out the hard way what happens when they arrive. The Asian giant hornet was first found in Washington state in December of 2019. A single dead specimen turned up in Blaine near the Canadian border. 2 years later, state agriculture crews were vacuuming a nest of nearly 1,500 hornets out of a tree in Whatcom County. In 2026, the USDA officially declared the Asian giant hornet eradicated from Washington state. That's good news. Nobody in the entomology world is celebrating loudly, though, because eradication in one county is not eradication in the country. The yellow-legged hornet has already made it to Georgia. The whole eastern United States has the climate and the honeybee density that these animals need. The story of hornets in North America is not over. It's chapter 1. Consider what that means. Every backyard hive, every commercial pollination operation, every almond grove in California, every apple orchard in Washington runs on European honeybees who have exactly zero evolutionary experience with the animal that just landed on their continent. They don't form heat balls. They don't recognize the alarm pheromone. They just get killed. And American commercial agriculture, which depends on those bees pollinating more than $100 billion of crops every year, has no plan B. And you, standing in your yard watching a large brown and orange insect land on your fence post, don't have great instincts either. You want to see it up close. You want to know what it is. That impulse, in the wrong yard, is the same impulse that put a Japanese hiker at the wrong end of a nest in 2013. Hornets are the insect that shouldn't work. Too big to be that maneuverable, too venomous for their body weight, too socially complex for a brain that small, too old to still be this ruthlessly effective. Every principle of small animal ecology says something should have replaced them by now. Nothing has. The blueprint that first shows up in Cretaceous amber, the same narrow waist and jointed antennae and hollow stinger you can still see in the display cases at the Smithsonian, is still the best blueprint in the game. The paper nest, the queen at the top, the daughters with knives, the chemistry that turns muscle into liquid, the coordination that lets a few dozen animals empty a hive of 30,000. The dinosaurs got their era. The mammals got their era. Insects have been quietly running the show underneath both of those eras for over 400 million years. And of all the insects that ever swarmed across this planet, the hornet may be the single most refined weapon system evolution has ever produced. Small enough to sit on your finger, complex enough to run a distributed civilization, old enough to have watched the entire mammalian family tree grow from nothing, and still, somehow, patient enough to wait 100 million years for a creature like us to walk out our back door and find out. If you ever wondered what an intelligent predator would look like if it were the size of a lipstick, you already know. It's outside. It's building a paper city in a tree hollow you never noticed, and it's watching what walks past. Thanks for watching, and I'll see you in the next one.